Hi, well, I'm Eli the Computer Guy. Today we're going to be talking about RAID. What is RAID? RAID stands for Redundant Array of Inexpensive Disks. Basically, what RAID allows you to do is to turn multiple physical hard drives into one logical hard drive that the computer sees. So imagine if you have 4 hard drives in a row and you don't want them to be considered individual hard drives by the computer. You can turn them into a RAID array and the computer will see them as one hard drive. Instead of seeing hard drives C, D, E, F, and G, it'll only see hard drive C. There's a lot of cool things that you can do with RAID, but there's also a lot of problems that come with it. So today we're going to be talking about RAID and how it can help and also hurt you and your computers. Okay, so we're going to start with the 3 basic types of RAID that you will normally see in the real world. RAID is designated by different numbers, from 0 all the way well past 10. There are only 3 types of RAID that are normally used by people and companies. That is RAID 0, RAID 1, and RAID 5. So 0, 1, and 5 are the standard forms of RAID that are used. RAID 0 is called RAID striping or disk striping. What disk striping does is it allows you to combine multiple hard drives of the same size into one really big disk. So you can have, for disk striping, you can have anywhere between 2 to 32 hard drives all in a disk striping array. So for the demonstration, we're just going to use 4. So imagine that you have 4 individual hard drives and that they are connected into a RAID 0 array, a disk striping array. Now what happens is, imagine these hard drives are all 250 gigabytes. So 250, 250, 250, and 250. In disk striping, that space is all additive. So it's 250 plus 250 plus 250 plus 250. So you have 4 250 gigabyte hard drives, and they are combined into one 1 terabyte logical hard drive. So when your computer sees this logical hard drive, this RAID array, it will think it is one really big 1 terabyte hard drive. That's pretty cool. How this happens is in disk striping, data is written to every single one of the drives, and so it's sequentially done. So if you're writing data to the hard drives, bit 1 will go to your first hard drive, bit 2 will go to the second, bit 3 will go to the third, bit 4 will go to the fourth, then bit 5 will go back to the first, then 6, 7, 8, 9, 10, 11, 12, off to billions and trillions and petazillions. So what happens is bit 1 gets put on the hard drive, bit 2 on the second, 3, the third on the third, the fourth on the fourth, and it keeps going along. So this is, it stripes the information across the drives. This makes writing and reading to hard drives faster, because instead of one hard drive having to pull all the data for a single document or file, you actually have all the hard drives in the array pulling their little bits. So it can make reading and writing to the hard drives much faster than you would get from a normal just 1 terabyte hard drive. Now here's the problem with disk striping, is if you notice, there's only little bits on each of these different hard drives. There's not full data on it. So this is bit 1 to, let's say, a Word document, and this is bit 2 to that same Word document. This is bit 3, again, to that same Word document. Well, here's the problem. If one of these hard drives fails in this array, then you lost all the bits that are on that hard drive. Not the data, but the bits. So if that document is striped across all of these hard drives and you lose this one little portion in the middle, that means your document is gone, your videos are gone. Any data residing on this RAID array is destroyed because a portion of the bits and bytes have vanished. So with RAID 0, it's very fast. It allows you to create a larger hard drive out of many smaller hard drives, but there's no redundancy. If a single hard drive fails, then all of your data has disappeared. So you have to make sure if you are using RAID 0 that you are using some kind of backup system, because imagine you know how often hard drives fail. If you put anywhere between 2 to 32 hard drives all in one computer, figure one hard drive in that computer is going to be failing at some point pretty quickly, and then all of your data will be gone. So RAID 0, very fast, creates big hard drives, but there's no redundancy whatsoever. Okay, so we just talked about RAID 0. Now we're going to be talking about RAID 1. RAID 1 is called disk mirroring. What disk mirroring does is it creates identical copies of your data. So with disk mirroring, you will only have 2 hard drives. And what happens is when data is written to one hard drive, it is automatically written to the other hard drive. So these disks are complete mirror images of each other. Everything that's on this hard drive is on this hard drive. Everything that's on this hard drive is on this hard drive. The nice part with disk mirroring is if one of your hard drives fails, your computer, your server stays up and running because you still have a complete intact copy of your data that's usable. With disk mirroring, what normally happens is you pull the bad hard drive out of the computer while it's still running. You're able to put a new hard drive in and it automatically rebuilds that mirror. Sometimes you have to manually press a button to make it happen, but it will start copying all the data from the good drive onto that brand new hard drive, and in a period of time you'll go back to having a disk mirror. And then if the other drive fails, you can pull that out, put the new one in. But with this is complete redundancy. You don't get any extra space considerations for this. If you have 250 gig hard drives, you still only get 250 gigabytes of storage space. You don't get any more because it's a mirror. There is nothing faster about this. This is about the same speed as a normal hard drive. Sometimes maybe slightly slower, probably not enough that you're going to notice. Okay, now the final normal type of RAID that you will be dealing with is RAID 5. This is disk striping with parity. So remember RAID 0, the disk striping where it striped information across multiple disks? Well, with disk striping with parity, you have the same thing, only you have some redundancy built in. So for disk striping with parity, RAID 5, you need to have at least 3 hard drives. This again can go all the way up to 32 hard drives if you really want to. Now what happens with disk striping with parity is bit 1 is written to the first hard drive, bit 2 is written to the second hard drive, and then the third hard drive has a duplicate of the first hard drive's data. And then the first hard drive gets a duplicate of the second hard drive's data, and then you go 3, 4. So it gets a little complicated to show on a whiteboard, but what happens is if one of these hard drives fail, the other 2 have all of the information that they need. So if one hard drive completely fails, it disappears, it's gone, all your data still exists because the other 2 hard drives still have the combined total information. So your documents, if one hard drive dies, you still have access to all of your documents or pictures or whatever data is on the server. Now again, just like disk mirroring, These hard drives are normally what are called hot swappable. Hot swappable means you can pull a hard drive out of the computer system while the computer system is running and put a new one in. So if this first hard drive failed, I would pull it out of the system, I would put in a brand new hard drive, and then the system would recreate that RAID 5 array. So it would start putting information back on this hard drive and make it part of the RAID again. So once that process is done, called rebuilding the array, then if the third hard drive fails, all your data still exists because the RAID is intact. Then you could put in a new hard drive here. Once the array has rebuilt itself, then if the middle one failed, you would still have all of your data. So the important part with RAID 5 is its disk striping, but it allows for one hard drive to fail and you keep all of your data. It improves your performance, so this will be faster than having a single hard drive on the system. It increases the space of that logical hard drive, but not as much as with disk striping, RAID 0. Since you have that one redundant disk, you lose that. So if we have three 250 gig hard drives here, so 250 gig, 250 gig, 250 gig, these are additive, so you add up 2, so you get 500 gig. But remember, one of your hard drives is for redundancy, so this doesn't give you any extra storage. So if you had three 250 gig hard drives, you would not get 750 gigs of usable space, you would only get 500 gigs of usable space. So the way you determine the usable space in a RAID 5 array is you add up all the disks that you're putting in the array, whether it's between 3 to 32. So if you had 32 250 gig hard drives in an array, to figure out how much space would be on that array, how much usable space, you would add up 32 times 250 gigabytes minus 1, because one of those hard drives is used for redundancy, not for data storage. Now, as I said, there are more RAID options than simply 0, 1, and 5. I think it goes up to somewhere around 14 right now. But all of the RAID options use the basic principles of RAID 0, disk striping, RAID 1, disk mirroring, and RAID 5, disk striping with parity. So let's say RAID 6. RAID 6 is basically like RAID 5, only you get an additional disk for redundancy. So it's disk striping with additional redundancy. So you have 2 hard drives that can fail and your RAID array still exists. Or if you get really complicated, you go all the way up to RAID 10. RAID 10 is mirrors of 2 RAID 5 arrays. So this is how complicated it can get. So you have disk striping with parity. So this is one hard drive, this is the other hard drive, and then RAID 10 is that these are actually mirrored. So if one hard drive here fails, it's no big deal. If one hard drive here fails, it's no big deal. If this entire RAID fails, then you still have some data left over. This is very expensive to implement and kind of complicated because you end up using 6 disks for only 2 disks worth of storage. But if you had a server that needed to be up all of the time, if you use RAID 10, 1, 2, 3, 4 out of 6 hard drives would have to fail before the system shut down. So things like that are options, but obviously you don't see them a lot because they're very expensive to maintain. Now that you understand what you're trying to accomplish with RAID, we'll go into how you create a RAID array. Now, what you're going to need to do to create a RAID array is, of course, multiple hard drives, but you will also need either what is called a hard drive controller or a piece of software to create the RAID array. Now, what a hard drive controller is it is a card like you would put in any normal computer or server. Nowadays, they're normally PCI Express cards. Sometimes you can find PCI cards out there, but they're normally PCI Express. Now, what happens is that card goes into your computer, and then all the hard drives that you want hooked into the array are then connected to that controller. When you boot up the computer, after the BIOS screen goes by, you're going to see another option that looks like a BIOS option that will allow you to configure the RAID controller. You access that, however it says, Control S, Control R. You go in there, and then it will give you options. It'll say how many hard drives it sees. It'll ask you how you want to configure those hard drives. Do you want those hard drives configured into a RAID 5? Do you want two, if you have 4 hard drives, do you want 2 sets of mirrors? So you have two hard drives are mirrored and the other 2 hard drives are mirrored. It'll ask you how you want the hard drives to be configured. Once you configure those hard drives, it'll go through a routine, and then the next time it boots up, the computer at the very lowest hardware level will see all of those hard drives as a single hard drive, or however you configure them. What is nice about this is that with hardware RAID, you can install an operating system onto the RAID array, because the computer physically thinks those 4 hard drives are 1 hard drive. You can then install the operating system onto that 1 hard drive. And so if we have RAID 5, disk striping with Parity, if 1 hard drive fails in that array, you can pull it out and replace it, and the computer can keep running. So even if the RAID that has your operating system on it, if one of the hard drives fails, you can replace it and the server stays up and running, and it's fine. There are no problems. Hardware RAID is generally very fast and can really give your computer a performance boost. Now, on the other side is software RAID. Software RAID is built into most operating systems now. It's been built into Windows servers, I think, since back in NT 4.0. Now, with software RAID, you have to already have an operating system in order to create the RAID. So it's good for storing data. So let's say you had a lot of company files that you wanted to store and you wanted to give them some redundancy. You would install one of the Windows Server operating systems like you normally do. And then within the Windows Server operating system, you would have the ability to configure a RAID of 0, 1, 5, I think they do more now, for a hard drive that stores data. So what's nice with this is that if any one of those hard drives that stores data fails, you can pull one out, put a new one in, and rebuild that array. All of your data is safe. You don't have to shut down the server. Here's the problem. If the hard drive containing your operating system dies, then the entire computer shuts down and goes away. So in this scenario, it's with software, it's less expensive because you generally do not have to buy anything. It's already part of the operating system that you own. But if the hard drive that contains the operating system dies, there's no redundancy for the operating system. As soon as the operating system fails, it goes away. Also, depending on how fast your computer is, the software, the operating system, is now responsible for that RAID. So if you don't have a lot of RAM or if you don't have a lot of processing power, you can dramatically slow down your computer because your operating system is now using RAM and CPU cycles in order to perform that RAID array. So that's one of the downsides with software RAID. So hardware RAID combines the hard drives logically at the hardware level. You can install an operating system on it. It's very fast, but it requires more money, basically. I have one hardware RAID. Again, my cost for it was about $900 for the card. Whereas software RAID, you don't generally pay a dime more for it. It's already part of the operating system you have, where there's a lot of freeware you can download to get it. On the other hand, your operating system has no redundancy because you already have to have an operating system running before you can create the RAID array. So hardware RAID, good, expensive. Software RAID, not so good, but basically free. So the next thing that we need to talk about is volume and size as it pertains to arrays. The first thing that we're going to talk about is the size of hard drives that can be used in arrays. Now, any size hard drive can be used. You can have a 750 gigabyte hard drive, you can have a 250 gigabyte hard drive, and you can have a 100 gigabyte hard drive, all in the same array. But what you have to understand is the size that can be used from any one hard drive can only be as large as the smallest hard drive. So we have one 750 gig hard drive, we have one 750, we have one 250 gigabyte hard drive, and we have one 100 gigabyte hard drive. So in this instance, if we had a RAID 5 array, we could only use 100 gigabytes from both the 250 and the 750 hard drive. So although this hard drive has 750 gigabytes on it, you can only use 100 gigabytes of it. Same with the 250 gigabytes. Because remember, the information gets striped across, so the drives have to be the same size that are allocated to the RAID. So if you have a 100 gig hard drive, even if these other hard drives are bigger, you can only allocate 100 gigabytes from each of these drives. So on a RAID 5, that means you get 300 gigabytes total, and then you get 200 gigabytes of usable volume. So let's do this again. So let's say we have two 500 gigabyte hard drives and one 250 gigabyte hard drive. So 500, 500, 250. So in this instance, the smallest hard drive is 250. So these two 500 gigabyte hard drives, you can only allocate 250 gigabytes from each. So only 250 goes into the array, 250. So now you have 750 gigabytes of total size for a RAID 5 array, and you actually have 500 gigabytes of storage space. So does that make sense? Let's do one more example. People get confused on this all the time. So if you have, let's say, 320 gigabyte hard drive, you have a 250 gigabyte hard drive, and you have a 500 gigabyte hard drive, what do you think the most you can take out of the 500 gigabyte hard drive is? How much can you use for the array? Since 250 gigabytes is the smallest hard drive here, then that's all you can take for your array. So again, instead of adding all this up, you get 250 gigs here, 250 gigs here, and 250 gigs here. So 750 gigabytes total, not 500, 750, not well over a terabyte of the total space. Because remember, the amount of hard drive space used for the RAID has to match for every hard drive. So you can't use 150 gigabytes of one hard drive and 100 gigabytes of another. You can only use 100 gigabytes, 100 gigabytes, 100 gigabytes, or 250 gigabytes, 250 gigabytes, 250 gigabytes. So the smallest drive is the largest size you can use for the array from the other hard drives. I hope that makes sense. So you can use different size hard drives, so you can put a 750 gigabyte hard drive with a 320 with a 250, but you will only be able to use 250 gigabytes out of that 750 for the array. Okay. Now the next thing that we need to talk about is size of the array and volume of the array. This normally really only comes up in conversation or on nasty little IT tests, such as if you go for your MCSE, your Microsoft Certified Systems Engineer, this will probably come up. So you have size of your array, size, and then you have volume of the array. Now what's the difference? They sound the same, but they are fundamentally different, and this can really mess you up. So the size of the array is the total amount of hard drive space allocated for the hard drive array. So if you have 4 250 gigabyte hard drives in any type of RAID, the size of the RAID would be 1 terabyte. So the size is the total size of all space allocated for that array. So if you have 2 250 gig hard drives in a mirror, you would have the size of that array, that size of that RAID would be 500 gigabytes. Now here's the thing, volume of the array is the amount of usable space. So the size of a RAID 0 or RAID 1 disk mirroring, 2 250 gig hard drives, the size of that array would be 500 gigabytes because you have 2 250 gigabyte hard drives in that array. Now since disk mirroring, that means one drive is an exact copy of the other, there's complete redundancy. The volume then is only 250 gigabytes because although you have 2 hard drives there, you really only have the usable capacity of 1. So the volume of that mirror is 250 gigabytes. Now this comes into play with, say, RAID 5. So you have 4 250 gigabyte hard drives in a RAID 5, which is disk striping with Parity. So the size, again, of that RAID array is 1 terabyte. It's 250 gigabytes plus 250 gigabytes plus 250 gigabytes plus 250 gigabytes gives you 1 terabyte. So the size is 1 terabyte. But the volume, that's different. Because remember, one of your hard drives is being used for redundancy. So you can't actually store any extra information on that. So if you have 4 250 gigabyte hard drives, but one is being used for redundancy, the volume of that then is 750 gigabytes. So although the size is 1 terabyte, you only have 750 gigabytes of usable storage space. So again, if you had 5 100 gigabyte hard drives in a RAID 5, then you would have a RAID that is 500 gigabytes in size. But remember, you have to take out 1 hard drive for volume because that's being used for redundancy. So you would only have 400 gigabytes of normal storage space. The only time this really doesn't come into play, of course, is with RAID 0 disk striping because all the disks are used in that RAID array. So if you have 4 500 gigabyte hard drives in disk striping RAID array, then you will have 2 terabytes of both size and volume. But that's the only time size and volume are equal. Now, so think about RAID 6. RAID 6 allows you 2 hard drives for redundancy. So again, if you had, let's say 6 250 gigabyte hard drives, the total size would be 1.5 terabytes because you have 6 250 gig hard drives. But the volume, since 2 drives are used for redundancy, the volume would only be 1 terabyte. So you lose a whole 500 gigabytes of volume by having that array. So just remember, size is the entire size of the array. It includes all the hard drive space that is allocated for the full array. Volume is the usable space within the array. So basically, take the size of the array minus whatever is used for redundancy, and that gets you volume. Okay, so that was the class on RAID, redundant array of inexpensive disks. We went over RAID 0, RAID 1, RAID 5, some of the hardware and software requirements. The last thing I will finish up with is talking about what happens if your server dies. Something happens, your server crashes. Now you need to be very, very, very careful with RAID hard drives. Within the RAID array, they are given a number in the ordering system. So hard drive 1, 2, 3, 4, 5. Now if your computer crashes for some reason, the one thing that you do not want to do ever, 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 ever is break that RAID array. You need to keep that RAID intact. So if you have hardware RAID, and I've seen this happen, don't go into that hardware configuration and then destroy the RAID and try to create another one. Because when you do, all of the data gets lost. Or if the hard drive, or if the server crashes, don't pull out the hard drives and stick them into some weird little data recovery devices, seeing if you can get anything off. Because in that process, you can damage the data that's on there, and if you put them back in, the computer might not be able to see any of that information, even when it is back up and running. So the main thing to remember is with RAIDs, if something happens to the computer overall, again, the operating system crashes, don't play around with those hard drives. If you don't really understand how RAID works, hire a professional to come in and take a look at it, because if you mess with that RAID, then all of your data can be gone. So that's a class on RAID. I hope you learned something. I'll see you at the next class. So, as a final note, you might ask me, so Eli, as a professional, so what do you really think of RAID? I mean, RAID seems really cool, but in the real world, how well does it work? And I'll tell you this, back in the day, RAID was one of the greatest inventions that they made for computers. But today, I wouldn't mess with it unless I really, really had to. Because remember, with computers, the more parts you put into a computer, the more things that can break. The more complicated you make a system, well, the more expensive the contractor or employee it's going to be to repair that complex system. So back in the day when hard drives maxed out at 10 gigabytes, even a small office might need some type of RAID array just to have enough storage on their little server so that everybody could upload their documents or whatever databases they have. Well, right now, September of 2009, we have 2 terabyte hard drives out there. Seagate just came out, it's 2 terabyte hard drive with 6 gigabit per second transfer rate. So, unless you're dealing with a large company, unless you're dealing with data centers, I don't see any reason to use RAID arrays. I have seen more often than not that the RAID controller itself fails, so it doesn't matter how redundant all your hard drives are. If the RAID controller fails, then what are you going to do? Especially think about it, that RAID controller is probably going to fail about 5 years after you bought the server. And so where are you going to buy a new RAID controller? You can't go to Best Buy to buy one of these things. Even if you bought it from Dell or Hewlett Packard, if you call them up, when are they going to get it to you? Even overnight is going to take till tomorrow, and that's if they have the thing in stock. RAID controllers are not something that anybody ever thinks about having a second one of, so it's not like you're going to have a redundant RAID controller sitting in a desk somewhere. So as it stands now, since we have 2 terabyte hard drives on the market, I don't believe RAID is worth it for the most part. Now again, if you're in a large company and you're dealing with petabytes of information, of course you need a RAID array. But if you are a small business or a home user, even a medium-sized business, I do not believe you need RAID. I believe a good backup system will do a lot better than RAID will. With the new backup systems that are out there, even if your hard drive fails, you can have everything back up and running within an hour or two. And the RAID, even though most of the time it is supposed to be hot swappable, a lot of times stupid things happen and it can take a lot longer than an hour or two to fix that RAID array. So I would say, as a professional in this day and age, don't mess with RAID. It's a really cool technology, but don't play with it. Say no.